Hello everyone. Today we are going to be continuing with our Nmap tutorial. We got up to here with performance, so I'm going to quickly read through this page. There doesn't seem to be any questions on it, but we'll get there. And then we'll go continue with the firewall, IDS, IPS evasion, all that stuff. And there's labs as well, I see. So hopefully we can do some of that. And yeah, let's just dive straight into it. All right, so performance. So scanning performance plays a significant role when we need to scan an extensive network or are dealing with low network bandwidth. We can use various options to tell Nmap how fast, with which frequency, and which timeouts the test packets should have, how many packets should be sent simultaneously, and with the number of retries for the scan ports the target should be scanned. Okay. Timeouts. When Nmap sends a packet, it takes some time, round trip time (RTT), to receive a response from the scanned port. Generally, Nmap starts with a high timeout, min RTT timeout of 100 milliseconds. Let's look at an example by scanning the whole network with 256 hosts, including the top 100 ports. Sudo Nmap, that thing, -f, top 100 ports, optimized RTT. So initial RTT 50 milliseconds, max RTT 100 milliseconds. Okay, when comparing the two scans, we can see that we found two hosts less with the optimized scan, but the scan took only a quarter of the time. From this, we can conclude that setting the initial RTT timeout to too short a time period may cause us to overlook hosts. Okay. Okay. Max retries. Another way to increase the scan speed is to specify the retry rate of the sent packets. Default value for the retry rate is 10, so if Nmap does not receive a response for a port, it will not send any more packets to the port and it will be skipped. Okay. We will not send any more packets to the port and will be skipped. Okay, reduce retries. So you've got max retries 0. Yep. Again, we recognize that accelerating can also have a negative effect on our results, which means we can overlook important information. Rates. During a white box penetration test, we may get whitelisted for the security systems to check the system and the network for vulnerabilities and not only test the protection measures. If we know the network bandwidth, we can work with the rate of packets sent, which significantly speeds up our scans with Nmap. When setting the minimum rate, min rate number for sending packets, we tell Nmap to simultaneously send the specified number of packets. It will attempt to maintain the rate accordingly. Okay. Tell Nmap to simply send the specified number of packets. Attempt to maintain the rate accordingly. Cool. Default scan, optimized scan. So you've got this min rate 300. So that's just how many packets it sends. Oh, it simultaneously sends a specified number of packets. Yeah. Okay. Okay. I'm not sure. Yeah, what that does exactly, but whatever. Default scan, found open ports. Pipe it into grep, pipe it into WCL. Okay. Timing. Because such settings cannot always be optimized manually, as in a black box penetration test, Nmap offers 6 different timing templates for us to use. These values determine the aggressiveness of our scans. This can also have a negative effect if the scan is too aggressive, and security systems may block us due to the produced network traffic. Default timing template used when we have to find nothing else is the normal T3. Aggressive and insane, polite, sneaky, paranoid. These templates contain options that we can also set manually, and have seen some of them already. Developers determined the values set for these templates according to their best results, making it easier for us to adapt our scans to the corresponding network environment. I'm drinking tea again. Anyway, the exact used options with their values we can find here. So, yeah, it's setting all these different things down here. RTT timeout. Yeah, so the max. So when you go up to in aggressiveness, the max RTT timeout goes downwards. Goes down because RTT is round trip time, and if you reduce the round trip time, yeah, it's the time to receive a response from the scan port. So if it's going downwards, it's like, okay, it's just quickly sending out more packets, right? We're not waiting. Yeah. And max retries. Okay, goes downwards with the more aggressive it gets. Default scan, insane scan, it's just going through those. Cool. Okay, that's not too interesting. Cool. Okay, firewall and IDS IPS evasion. Nmap gives us many different ways to bypass firewall rules and IDS IPS. These methods include the fragmentation of packets, the use of decoys, and others that we will discuss in this section. Firewalls. Firewall is a security measure against unauthorized connection attempts from external networks. Every firewall security system is based on a software component that monitors network traffic between the firewall and incoming data connections and decides how to handle the connection based on the rules that have been set. It checks whether individual network packets are being passed, ignored, or blocked. This mechanism is designed to prevent unwanted connections that could be potentially dangerous. IDS and IPS, like the firewall, the intrusion detection system and intrusion prevention system, are also software-based components. IDS scans the network for potential attacks, analyzes them, and reports any detected attacks. IPS complements IDS by taking specific defensive measures if a potential attack should have been detected. The analysis of such attacks is based on pattern matching and signatures. If specific patterns are detected, such as service detection scan, IPS may prevent pending connection attempts. Determine firewalls and their rules. We already know that when a port is shown as filtered, it can have several reasons. In most cases, firewalls have certain rules that set to handle specific connections. The packets can either be dropped or rejected. Dropped packets are ignored and no response is returned from the host. This is different from rejected packets that are returned with an RST flag, reset flag. These packets can contain different types of ICMP error codes or contain nothing at all. Such errors can be unreachable, prohibited, unreachable, prohibited, net, host, and port. Okay. Nmap's TCP ACK scan or SA method is much harder to filter for firewalls and IDS IPS systems than regular SYN or connect scans because they only send a TCP packet with only the ACK flag. When a port is closed or open, the host must respond with an RST flag. Unlike outgoing connections, all connection attempts with the SYN flag from external networks are usually blocked by firewalls. However, the packets with the ACK flag often pass by the firewall because the firewall cannot determine whether the connection was first established from an external network or the internal network. If we look at these scans, you will see how the results differ. So here they're doing the SYN scan. And, okay, here we're doing the ACK scan. So you get filtered, open filtered, filtered, unfiltered, filtered. Okay. Please pay attention to the receive packets and its set flag we receive from our target. Okay. With the SYN scan, our target tries to establish a TCP connection by sending the packet back with the SA flag set. And with the ACK scan, we get the RST flag because TCP port 22 is open. Okay, let's have a look at this. So you're telling us to look at the received packets. So these ones down here. So it's saying, with the SS scan, our target tries to establish a TCP connection by sending a packet back with the SYN flag set. A bit confusing to me, but okay. These ones received. You get this type code equals 3, which is, yep. With the ACK scan, we got the reset flag because TCP port 22 is open. For the TCP port 25, we do not receive any packets back, which indicates the packets will be dropped. Okay. Let's move on from that. Detect IDS IPS. Unlike firewalls and their rules, the detection of IDS IPS systems is much more difficult because they are passive traffic monitoring systems. IDS systems examine all connections between the hosts. If the IDS finds packets containing the defined contents or specifications, the administrator is notified and takes appropriate action in the worst case. IPS systems take measures configured by the administrator independently to prevent potential attacks automatically. It is essential to know that IDS and IPS are different applications and that IPS serves as a complement to IDS. So IDS is intrusion detection, IPS is intrusion prevention. Cool. Several virtual private servers (VPS) with different IP addresses are recommended to determine whether such systems are on the target network during the penetration test. If the administrator detects such a potential attack on the target network, the first step is to block the IP address from which the potential attack comes. As a result, we will no longer be able to access the network using the IP address, and our ISP will be contacted and blocked from all access to the internet. Yeah. They'll block the IP address from which block your IP address, basically. IDS systems alone are usually there to help administrators detect potential attacks on their network. They can then decide how to handle such connections. We can trigger certain security measures from an administrator, for example, by aggressively scanning a single port and its service. Based on whether specific security measures are taken, we can detect if the network has some monitoring applications or not. One method to determine whether such IPS system is present in the target network is to scan from a single host, VPS. If at any time the host is blocked and has no access to the target network, we know the administrator has taken some security measures. Accordingly, we can continue our penetration test with another VPS. Consequently, we know that we need to be quieter with our scans and, in the best case, disguise all interactions with the target network and its services. Decoys. There are cases in which administrators block specific subnets from different regions in principle. This prevents any access to the target network. Another example is when the IPS should block us. For this reason, the decoy scanner method is the right choice. With this method, Nmap generates various random IP addresses inserted into the IP header to disguise the origin of the packet sent. With this method, we can generate random RND, a specific number, for example 5, of IP addresses separated by a colon. Our real IP address is then randomly placed between the generated IP addresses. In the next example, our real IP address is therefore placed in the second position. Another critical point is that the decoys must be kept alive, or must be alive. Otherwise, the service on the target may be unreachable due to SYN flooding security mechanisms. Okay. Decoy random 5, and you can see these are random IP addresses 161.59. What is all different IP addresses? Okay. Cool. Port 80 is actually scan a particular port. The spoof packets are often filtered out by ISPs and routers, even though they come from the same network range. Therefore, we could also specify our VPS server's IP addresses and use them in combination with IP ID manipulation in the IP headers to scan and target. Another scenario would be that only individual subnets would not have access to the service-specific services. So we can also manually specify the source IP address to test if we get better results with this one. Decoys can be used for SYN, ACK, ICMP scans, and OS detection scans. So let's look at such an example and determine which operating system is most likely to be. Testing firewall rule -npn p450. Okay. Let's do an operating system scan. -o. Aggressive OS guesses. Okay. DNS proxying. By default, Nmap performs a reverse DNS resolution unless otherwise specified to find more important information about our target. These DNS queries are also passed in most cases because the given web server is supposed to be found and visited. The DNS queries are made over the UDP port 53. TCP port 53 was previously only used for the so-called zone transfers between the DNS servers or data transfer larger than 512 bytes. More and more, this is changing due to IP version 6 and DNSSEC expansions. These changes cause many DNS requests to be made via TCP port 53. However, Nmap still gives us a way to specify DNS servers ourselves. This method could be fundamental to us if we are in a demilitarized zone, DMZ. The company's DNS servers are usually more trusted than those from the internet. So, for example, we could use them to interact with the hosts of the internal network. As another example, we can use TCP port 53 as a source port for our scans. If the administrator uses the firewall to control this port and does not filter IDS/IPS properly, our TCP packets will be trusted and passed through. Okay, this is quite advanced technical stuff, but we'll move over it from now. We'll try and go into the labs. Now that we have found out the firewall accepts TCP port 53, it's very likely IDS/IPS filters might also be configured much weaker than others. We can test this by trying to connect to the port by using netcat, ncat, nv source, blah blah blah. In the next three sections, we get different scenarios to practice where we have to scan our target. Firewall rules and IDS/IPS protect the system, so we need to use the techniques shown to bypass the firewall rules and do this as quietly as possible. Otherwise, we will be blocked by IPS. Okay, cool. Okay, so am I recording? Am I recording the right thing? Is this recording? Windows capture. Why does this look like it's not recording? There we go. Sorry, yeah, no, I put the video on pause. So let's continue where we left off. Firewall, IDS, IPS evasion, an easy lab. So let's get practical. Company hired us to test their IT security defenses, including the IDS and IPS systems. Our client wants to increase their IT security and will therefore make specific improvements to their IDS, IPS systems after each successful test. We do not know, however, according to which guidelines these changes will be made. Our goal is to find out specific information from the given situations. We are only ever provided with a machine protected by IDS/IPS systems and can be tested. For learning purposes and to get a feel for how IDS/IPS can behave, we have access to a status web page. I'm drinking apple juice now, by the way. It's just so you know. Anyway, this page shows us the number of alerts. We know that if we receive a specific amount of alerts, we will be banned. Therefore, we have to test the target system as quietly as possible. Okay. Spawn the target machine. Client wants to know if you can identify which operating system the provided machine is running on, submit the OS name as the answer. Right. And let's go full screen. Cool. Okay. Let's get bash script open, and we want to do an operating system scan, but a quiet operating system scan. So if we go back, log in again. If we go to maybe this one of these told us how to do it quietly. How do we do it quiet? Maybe we can do it with the. It was this? It was under here, wasn't it? It was something to do with this. Paranoid, the aggressiveness. Dash T0. I'm not sure what that dash ON. Save the results in normal formats. It doesn't actually show you. This is being really dodgy, but it says saves the results in normal formats. Something's unspecified name. Okay. Just quickly remind myself what the scripted engine is as well. Create scripts in Lua for interaction with certain services. Gosh. I don't think any of that. Oh, I don't think we've answered that. Okay, we'll come back to that one maybe a bit later. Okay. Any of this interesting, useful? Was it the ACK scan was harder to detect? You only send a TCP packet with only the ACK flag. Okay, so that's one possibility as well. And there's decoys, decoys as well. Yep. Okay, Nmap. What exactly are we trying to do? Spawn. Waiting. That's not very good. Let me refresh this page. It's all gone. It's all gone to hell in a handbasket. Why is this not waiting? Come on. I lost internet connection, have I? No. Come on. There we go. Spawn the target. Oh god, it's not working. Of course it's not working. Why would it ever work? So I'll have to pause here. Okay. Oh, it's unscrewed itself now, so we're back in business. We've got this target. Which operating system? So I believe it was a -O. Can we just paste? Is it like that? Is that how you do it? I want to say. And then this T thing. So you do what? -T0 for paranoid. Let's do -T0. -T0. See what happens. Oh, we need to do a sudo. Sudo. See what it says about operating. Well, actually, starting. This is going to take a lot longer, I think, because the timeout is longer. The initial max timeout, and yeah. Extraordinarily long time to scan thousands of machines or ports. You may prefer to set the exact timing values. Okay, this is going to take a long time, I think. I think what we want. Oh god. Maybe we don't want 2.0. Maybe we want T2. I have a feeling that's going to take way too long. Maybe we want. Maybe we put that T2. Any other evasion techniques that we can do? That's. I don't know. Sorry, lost concentration. Just quickly read the operation system OS detection. Okay. Well, let's just try it first with, because that thing was saying beforehand. Saying here that emit inversion detection. Okay. If I just set the exact timing values you need rather than rely on the CAN T0 and T1 values. Okay, so instead of doing that, so max retries. So okay, we can change max retries, and we can change this RTT timeout value. So generally, Nmap starts with a high timeout. So the default scan and optimize one, they've got the initial timeout to 50 and the max timeout to 100. Frequency, which time it's. So generally, I think if you want it faster, you want a lower timeout before it sends the next. Before it, that's kind of how long it's waiting, I guess, for a response or something, right? So generally, it's saying that it starts with a high timeout of 100 milliseconds. Yeah. So I guess it's some reason it can change from the initial to a max or something. So you want a lower timeout to speed it up, right? Comparing the two scans, we found that we found 2 hosts less with the optimized scan, but the scanner took a quarter of the time. We conclude that setting the initial timeout to too short a period may cause us to overlook hosts. In other words, to increase the scan speed, specify a retry rate. So I'm guessing you want a lower retry rate as well. The default is 10, right? Here, so okay, you can do. Let's just do it as a. Let's just do T2 -T2. Polite. So that's all that is doing is the max timeout, as I say. So compare it to normal. So the timeouts are the same. The max retries is the same. The initial and minimum scan delay has gone up to 400. Not sure exactly what that is. Parallelism is 1. Okay. Okay. Well, let's just try it with T2. It might be a bit slow, but I'll skip ahead if that's the case. It might not work at all. So I just try to see as well for operating for the for operating system OS detection if there's anything else that's interesting. Try hosts. Specify a lower max OS try speeds Nmap up. So maybe we want to. So maybe we want to set the max OS tries to the lower value. We've got this status thing, right? We can do it as much as we want, right? I mean, there's nothing. We can use decoys maybe. We can test the firewall rule. Okay, there's all this DNS proxying. God. Okay. So yeah, there's this target status thing. Shows number of alerts. We know if you receive a specific amount of alerts, we'll be banned. Therefore, we have to test the target system as quietly as possible. Okay, let's just quickly get that up as well. God, I hate the fact that I have to refresh this every time. Still have to work out why that's the case. But let's have a look at this status thing. Or at least I would if the paste would work. Paste and go. No. Okay, cool. And I think target has to be the IP address that we're looking at, which is this one. Just get it up. Recorded alerts. 16 out of 100 alerts. Eh? We didn't even do anything. Did we run it? Oh god. Maybe we ran it. Did we? We tried something already, didn't we? Maybe this won't work. Not that. That's worrying. Let's try it. Okay, well. Oh yeah, no, this is going up. This is getting alerted. Okay, yeah, we might want to stop this if it's gonna. Okay, just stop it. We've got to stop that because it's yeah, we're hitting the IPS. So we might want to do some of this evasion stuff. Okay. IDS systems examine all connections. IPS takes measured configured. We can do something like this, which is they did an O scan here and they used a different source IP. God, I hate the fact that it doesn't do that. It doesn't tell you exactly what it says. You know what? I don't have to do that. Scans the target by using a different source IP address. Sends all requests through the specified interface. Disables IMCMP echo requests. I don't know. I don't know if any of that's going to help. Maybe we want to do that. Maybe you want to use a different source IP address. Let's try that. Okay. Let's do that with the T1. And yeah, screw it, let's do that. Dash S, let's copy it exactly. Dash S 10.129.2.200. If S is being used to affect your source address, you may also have to use interface and PN. If you're using it to specify your real source, I could not figure out which device to send the packet out on with the source address you gave me. If you're trying to spoof your scan, this is normal, just give the E. Otherwise, you still use E, but I find it kind of fishy. Okay, cool. Let's do the dash E then. And ton 0. And what he also wanted, something else. And dash PN, which was for disabling ICMP requests. I don't know why you'd have to do that, but whatever. Dash PN. Okay, this may take some time, but oh god. Fail to determine route. Okay. Fantastic. Okay, let's get rid of all that then. Just do ton10. And we're just gonna have to wait, I think. I think that's the only solution to this. So I'm gonna pause the video. And yeah, we'll wait. Sorry, I paused the video again. Where are we at? So our client wants to know if you can identify which operating system their provided machine is running on, submit the OS name as the answer. I didn't read the hint, and the hint says that we don't actually need to do an OS scan. So it says, remember, you don't need to provide a version of it. Think about which services can give you information about the operating system. After interviewing the administrators, we found out that they want to prevent neighboring hosts of their 24 subnet mask from communicating with each other. Services give you information about the operating system. There's the time to live thing. There's that time to live thing. So maybe if we go back here. Just quickly operating system. It wasn't this one. Maybe service enumeration. Operating. Time to live. Time to live. TTL. No. Go back here. TTL. Maybe it was down in the question. Maybe it was one of the questions. The host name. So we could do an SU. Gives us UDP scan. I think the time to live of the packets gives us some more information. Okay. So yeah. Saving the results in different ways. We want something that's going to give us time to live. I think that's pretty much it. I think that's what we want. So packet trace N disable B. Something like that may do it. I never really understood why we do all this. Well, they did this. We deactivate the ICMP echo request DNS resolution on pin scan. It enables them to track how the sent packets are handled. Not really sure why you want to do that. Okay, well, let's try something. We've got this, and it's minimized itself. Okay, Nmap and IP address we want there. I think we don't want to change that -t option, which was what the performance thing. I'm not sure that's what we want to do because it's saying the thing we want to do is services. Look at the services. I find they want to prevent neighboring hosts of their -24 subnet mask. What is the -24 subnet mask? -24 subnet mask. Let's have a quick look. Addresses net mask. What? Not sure what that is. Addresses hosts net mask. I have absolutely no idea what this is. Okay. Well, the idea of a subnet mask is, I was looking this up before. That's subnetting, but a subnet mask is simply something like 255.255.255, which when you put in binary, and then all you do is I think all that happens is that it separates. If you AND them together, or if you XOR them together, you do something like that. Yeah, I think it's if you AND them together, then you get this, right? Which is the network address. So yeah, if you AND it together, so that's when the ones are the same. It produces a 1, otherwise it doesn't produce anything. It doesn't equal anything. Yeah. Basically, it separates it into the network address and the host address. Something along those lines. So yeah, when a packet arrives on the 192.168.123.0 subnet and it has a destination address of 132, the computer will receive from the network and process it. Almost all decimal subnet masks convert to binary that are all ones on the left and all zeros on the right. And there's a few others as well. Okay. Anyway, so this is getting away from what we actually want, which is how to do this. If we can identify which operating system they provide a machine on, so the answer. After interviewing the administrators, we found out they want to prevent neighboring hosts of their 24 subnet mask from communicating with each other. God, I don't know. Okay, let's try and just copy one of the scans they did here. Can you do SV -P- all open ports -P- -SV. We want something that's going to give us the time to live values, because I think that's what's going to give us the operating system. So let's find one that did that. Oh God. It wasn't here. So this is taking so long. Do something which is probably very simple. This one here looks promising. So you've got the dash P, it's given the port, so you can skip that. But packet trace, dash PNN, all these options here. Maybe that will do that. So we want these options. And maybe, was it an ACK scan is quieter? God knows. Performance, was it an ACK scan is quieter? Or try the retray. We can try maybe some of these options, but whatever. Let's just see what happens if we do it like this. I don't know. Was it? ACK. Maybe there's something in this tutorial about this book about firewall IDS evasion. Here we go. It takes skill experience. The tutorial is built on the scope of this reference guide. You list the relevant options, describes what they do. Awesome. Spoofing the source address. We tried that, didn't we? IP options. Set IP time to live field. Randomize hosts. Proxies. Bad sum. God. This is interesting. Let me just read this. Fragment packets. Dash F option causes the requested scan, including host discovery SANs, to use tiny fragmented IP packets. The idea is to split up the TCP header over several packets to make it harder for packet filters, intrusion detection system, and other noise systems to detect what you are doing. Be careful with this. Some programs have trouble handling these tiny packets. The old school sniffer named Sniffed segmentation faulted immediately upon receiving the first fragment. Specify this option once, and Nmap splits the packets into 8 bytes or less than the IP header. So a 20-byte TCP header would be split into 3 packets. Okay, 2 with 8 bytes of the TCP header and 1 with the final 4. Of course, each fragment also has an IP header. Specify -F again to use 16 bytes per fragment. Reduce the number of fragments, or you can specify your own offset with the MTU option. Don't also specify -F if you use -MTU. Offset must be a multiple of 8. While fragmenting packets won't get by packet filters and firewalls that kill IP fragments, such as the config IP always defrag option in the Linux kernel, some networks can't afford the performance hit this causes and thus leave it disabled. Others can't enable this because fragments may take different routes into their networks. Some source systems defragment outgoing packets in the kernel. Linux with the IP tables connection tracking module is one such example. There is scan with a sniffer such as Wireshark is run to ensure that such the same fragments are fragmented. If your host OS is causing problems, try the --send ether option to bypass the IP layer and send raw Ethernet frames. Fragmentation is only supported for Nmap's raw packet features, which include TCP and UDP port scans, except connect scan, FTP bound scan, and OS detection. La-di-da-di-da. La-di-da-di-da. I don't think we need to use decoys. I know this wasn't mentioned in the tutorial, so I'm just, not gonna do it. Okay, look. I don't really know what I'm doing here. Let's just see what happens. Oh, wow, okay. Something happened. So quickly maximize this again. And let's go on to that thing that it said. That thing that it said, this website here. Yeah. Come on. Paste. Oh, don't paste. Is it going to paste? No. It's also minimized. Gosh. Come on. One last try. No, it's not going to paste. Okay. That. Paste. Please work. Cool. And we want this. Da 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 da. Okay. Well, we paste that there. Wow, this really is annoying me now. God, no. Come on. 10.129.2.80. 10.129 point something 0.80.2.80. That doesn't sound like an IP address. 2.80. Yeah, it is. Okay, whatever. Status 17 over 100. Fine, we're good. We're good. We're good. Cool. Bunch of things. Connection refused for a lot of it. So you see it's trying all these different ports. Operation connection refused. Operation now in progress. God. So these are all the port numbers on the right. They tried. Packet trace PNN. Disable what ping. God. Okay, whatever. Anyway, host is up. Connection refused. Filtered ports. Service HTTP SCP config. So you don't need to provide a version. Think about which services give you information about the operating system. Can we do a service version scan or something? Is it literally just asking us which OS it's on? To prevent neighboring hosts of that. What does that mean? The 24 subnet masks will communicating with each other. Addresses hosts amount of a class C. So you have network classes. Okay. Class C networks use a default subnet mask of that and have 192.1.223 as the first octet. Address, blah 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 blah. Blah blah blah. The first octet gives you the class. Okay, it's not very useful. But is that like how many hosts it can have, and that's how many IP addresses it can have, or something? Don't really know. SSH HTTP SCP config. What is SCP config again? SCP config. What is SCP config? Copies files between hosts on a network. Uses SSH one for data transfer. Uses the same authentication it provides. So if they're trying to stop this, port runs on port 22. This isn't running on port 22. It's running on port 10001. So a quick look at what this says. Copies files, uses SSH for data transfer and uses the same authentication provided for same security. SCP will, it's a secure copy, isn't it? This is the config for it. Attack no. Okay, that's not very useful, but I want to find out they want to prevent communicating with each other. So maybe it's something to do with that. Can we do a similar scam, but with SV? So maybe that will give us, because the version, because I kind of, oh god, this thing is NSOC connect, oh no, timeouts, callback read success, service scan match, so you actually, Ubuntu, haha, we have something. There you go. Okay, I'm not sure if we did this the right way, but whatever. What is NSOC? God, there's so much I don't know. NSOC, NBSOC, no, NSOC, NSOC, NSOC. What is NSOC? Parallel sockets library used by NSC service detection and DNS access and abstraction above socket operations. Twice for handling. It's a sockets library. Okay. NSOC IOD delete, NSOC IOD delete. So trace handler right, blah de blah de blah de blah. I don't have a feeling this is taking a long time. Service scans and improved terminal service cookie, TLS session requirement, Kerberos, service scan sending probe. What does that even mean? Okay, service scan, which is what we're doing. Service scan sending probe. So how service scan is what if I send some probe data to the port and monitoring the response. For example, sending get as a probe could detect a web server, and the exact response will give some indication which server. I can literally look at just the service scan. The Nmap service scan captures information from unidentified ports, and users are encouraged to submit details of these. Almost all vulnerability scans we put in the service scan. Blah de blah de blah de blah de blah. Awesome. So it's, is it? I'm just I'm a little bit confused whether we're doing the right thing or not. Or what's this down here? Oh. Awesome. What's that down there as well? Automatic sleep enabled. Jesus. Okay. Let's just stop this because we saw Ubuntu. You know, I think that's all we need. And I think, unfortunately, it's probably we're gonna have broken this thing. Yeah. Let's just do Ubuntu. There you go. We cheated. Well, I don't know if we cheated, but we definitely didn't do everything completely correctly. After we conducted the first test and submitted our results, the administrators made some changes and improvements to the IDS, IPS, and firewall. We could hear the administrators were not satisfied with their previous configurations during the meeting, and they could see that the network traffic could be filtered more strictly. God. Spawn this target. After the configurations are transferred to the system, our client wants to know if it's possible to find out our target's DNS server version. Submit the DNS server version of the target as the answer. The client wants to know if it's possible to find out the target's DNS server version. How the hell am I going to find the DNS server version of the target? Hint about the host we tested as a publicly accessible server that was not mentioned before. I have no idea. Public accessible server. Maybe if we just... This is going to sound really stupid, but what happens if we just go to it then? If it's publicly accessible. Let's just... I don't care about this, but if we go to... God, it really does not like to copy, doesn't it? What? What do you want about? This thing, 48. Let's go to it. Okay, Apache 2 Ubuntu default page. A default welcome page to test the correct operation of Apache 2 server after installation. What was the question? Submit the DNS server version of the target. Domain name server. Possible to find out the target's version. Oh my god. What is this? Apache HTTP server installed. Configuration overview. Okay. So maybe the DNS server version is somewhere in one of these files, on these config files. I mean, there was a DNS server scan or something to do with DNS service enumeration, maybe. I don't know, it's just there was something we did with DNS. Maybe not. Maybe not there. Maybe here. It's definitely something we did with DNS. DNS resolution. We don't want to disable DNS resolution. Maybe we just do the standard scan. Is that really stupid? Because -n disables DNS resolution, but we don't want to disable DNS resolution. We want to know the DNS. Client wants to know if it's possible to find out our target's DNS server version. Well, this is all some complicated stuff. Let's just try and do a basic scan. Nmap of full rate. We don't need any of this stuff. Let's just try. What's going to happen if we just do full rate? Screw it. Let's do a standard scan. There you go. Filtered Microsoft DNS. How to find DNS. How to find DNS server version using Nmap. Oh, God. DNS for RDNS from your resolve.config file. Jesus. So Nmap runs a reverse DNS resolution on your respective host. Oh God. I think we were right with what we said beforehand, with literally just looking at this page here. So maybe we want to get this. Apache 2 config is the main configuration file. Puts the pieces together by including all remaining configuration files. Activated by symlink and available configuration files. Binary is called Apache 2. By default, Ubuntu does not allow access through the web browser to any file part of those located in public HTML directories when enabled. Ooh, okay. Gosh, I'm getting into the weeds here. I don't know. I don't know. I want to get to that. Should I just do etc Apache 2 after it? See what happens. etc dash Apache 2. This isn't going to work, but not found. Ubuntu server. Yeah, we're not doing that correctly. Oh God. Does not allow access through the web browser to any file that is located in public HTML. Using a web document root, you may need to whitelist your document root directory. So you can make virtual hosts. I have no idea what I'm doing. Well, when we did that Nmap scan, what did it tell us? Tell us a bunch of filtered Microsoft DS domain. What's service domain? No, 53. Port 53. Domain name service. Here we go. Used for domain name resolution. Awesome. Go and proceed. There are some attacks that target vulnerabilities within DNS. Okay, cool. Well, we're not trying to exploit it, we're just trying to scan it. Now, if it's filtered, remember what filtered means. If you go all the way back to filtered. So filtered, basically filtered means that it can't tell. Something like that, wasn't it? Maybe it's introduction. No, filtered. Nmap does not receive a packet back that displays as filtered. Maybe dropped or ignored. It's the default SYN scan. So what can we do with the filtered scan? How to tell, okay. What can we do with a filtered port Nmap? Filter means a firewall is blocking the port. Okay. Close ports and no application listening to them. So there is something on that. So we've got as far as working out that it's about the DNS server version. Maybe we just want to literally just do an SV of that Nmap, and then we can do -p-53, and then do -sv. Maybe that would do it. Maybe it's literally that simple, just finding the version. Would it do it though? I think I mucked up. I don't think we wouldn't do -p-. We want to do -p3. Brr. Service detection performed. It doesn't tell us which version. Scheiße. Is there anything in here? Anything in here? Helps us. Portion is filled for several reasons. In most cases, firewalls have certain rules. Dropped or rejected because dropped, receives no package. Okay. Cool. Used scanning options. We've seen the last one, it's in 2 packets. Oh god. So and the firewall is port's rejected, then we'll have to take a closer look at the port later. How do we open up the port? Okay, let me pause the video and do a bit of research into how to get past this filter. Well, I found a whole chapter in this book about detecting and subverting firewalls and intrusion detection systems, which is probably where we want to be looking at. So bypassing firewall rules. So here they're using something called a FinScan, so with this -sf. So maybe we want to do that. So FinScan is, I don't exactly know what a FinScan is, to be honest. Scan types of fin. What is a FinScan? A FinScan. FinScan and map. FinScan, sheer stupidity of old and stateless firewalls. When it comes to FinScan, a port scanner sends a packet with a flag in the form of fin, meaning at the end of the session. Okay. What is a stateless file? They think to themselves that there probably was a session beforehand, and now it wants to end. So they allow the data packets to pass. Typically, this type of scanner is not very suitable for work. It's been replaced by more advanced port scanners. But in any case, this type of scanner can be used for DOS attacks. Okay, well, maybe we want to do that. Maybe we try. What is a stateless file? Quickly, stateless firewall. Just have a quick Google. Designed to protect network space and static information such as source and destination. Okay. Okay, so it's filtering against stateful firewalls, capable of monitoring and detecting the states of all traffic on a network. Stateless individual packets using preset rules. Okay, let's try, and it's doing the T4 as well, T4 approach. Let's try that. See if that works. So, was it SF and T4? T4. Let's go. Sudo Nmap. Let's go. That hasn't helped. That hasn't helped at all. Open filtered. Hasn't really helped at all. I mean, our goal is to get the version of the DNS servers, right? Our goal is to get the version of the DNS. I'm not really sure. Okay. Source port manipulation. Exploit these weaknesses. God. What's that about 24? I just saw something 24, which is what we were talking about beforehand. Might be worth just reading this. Practical real-life example, firewall subversion. Now that many individual techniques of bypassing firewalls have been covered, it's time to put them together in a real-life penetration testing scenario. Also with a post, the security-focused pen test list from security pro Michael Kane. He and co-worker Dimitris Papatrao, penetration testing internal network of a large corporation, had just bypassed firewall rules meant to prevent one VLAN from accessing another. It's pleased to read that they performed this feat using Nmap, and I wrote them for the whole story. Both instructional and inspirational in that it demonstrates the value of perseverance in trying every technique you know, even after the most common exploits fail. Don't let that firewall beat you. Okay, story starts with Michael Dimitris performing an Nmap scan, which shows they are stuck on a heavily filtered network. They can reach some corporate servers, but not any of the potentially vulnerable desktop client machines, which have to exist somewhere on the network. Perhaps they're in a restricted conference room or lobby network, or maybe a wireless access point set for corporate guests. Some undiscovered hosted networks are shown. Okay. A few details on the story have been changed for confidentiality to call the target Megacorp. Router firewall. Protagonist is scanning from this machine. Files to Megacorp. Which is a Windows machine. Okay. Simple pin scan. Pin scan fails to find responsive hosts. This makes the section more interesting and instructive. That's the network extremely empty but compact with vulnerable machines. Deeper specifies packet tracing and extra verbosity options to determine what is going on the packet level. The reason for choosing just one IP is to avoid a confusing flood of hundreds of packets. Okay. Maybe we want to quickly, actually, because this is bypassing the rules, but maybe we want to determine the firewall rules first. Systems require to send a negative response to unexpected connection requests in the form of the TCP reset packet. RST packet makes closed ports easy for Nmap to recognize. Filtering devices such as firewalls, on the other hand, tend to drop packets destined for disallowed ports. In some cases, they send ICMP error messages, usually port unreachable. Instead, because drop packets and ICMP errors are easily distinguishable from RST packets, Nmap can reliably detect filtered TCP ports from open and closed ones. It does so automatically. Blah 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 blah. Not shown filter ports. Probably denied by default firewall policy. Only those ports seem to explicitly out reachable, while the default action is to deny them. 3 of the enumerated ports are in the open state, and the other 3 are closed. The remaining are reachable by the standard scan. Okay. So what have our scans revealed so far? Bunch of open ports. 992 closed ports. I really don't know. What is all this? So the reference guide for that's just, that's not what we want. This one. Axe scan. Okay, sneaky firewalls that return reset. RST. Well, the Nmap distinction between closed ports and filtered ports is usually accurate. Many firewalls devices are now capable of forging RST packets as though they are coming from the destination host and claiming that the port is closed. One example of this capability is the Linux IP table system, which offers many methods for rejecting undesired packets. The IP table's man page documents this feature as follows: reject with type. The type given can be ICMP net unreachable, ICMP host unreachable. Blah 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 blah. Okay, so you can forge RST packets. Okay, it's not particularly common outside of port 1 and 3, as it can be confusing to legitimate network operators, and it also allows scanners to move on to the next port immediately without waiting on the timeout caused by drop packets. Nevertheless, it does happen. Such forgery can usually be detected by careful analysis of the RST packets in comparison with other packets sent by the machine. Oh god. Okay. Axe scan. Describe. I feel the axe scan might be useful here. ACK scan sends TCP packets with only the ACK bit sent. Whether ports are open or closed, a target is required to respond with a reset packet. Firewalls that block the probe, on the other hand, usually make no response or send back an ICMP destination unreachable error. This distinction allows Nmap to report whether the ACK packets are being filtered. The set of filtered ports is often smaller than for a SYN scan against the same machine because ACK scans are more difficult to filter. Many networks allow nearly unrestricted outbound connections but wish to block internet hosts from initiation connections. Many networks allow nearly unrestricted outbound connections, which to block internet hosts from initiating connections back to them. Blocking incoming SIM packets without the ACK bit set is an easy way to do this, but it still allows any ACK packets through. Blocking those ACK packets is more difficult because they do not tell which side started the connection. To block unsolicited ACK packets or allowing ACK packets to belong to legitimate connections, firewalls will statefully watch every established connection to determine whether a given ACK is appropriate. These stateful firewalls are usually more secure because they can be more restrictive. Blocking ACK scans is one extra available restriction. Downsides are that they require more resources to function. A stateful firewall reboot can cause the device to lose state and terminate all established connections passing through it. Stateful firewalls are widespread and rising popularity. The stateless approach is still quite common. For example, the Linux net. Okay, cool. In the previous section, scan. Maybe we want to do this. Maybe we want to do an ACK scan. Is there anything here? Anything here that's going to help us with version scanning? Hello. Previous section will focus on prevalent TCP, but working with the UDP is often more difficult because the protocol does not provide acknowledgement of open ports. Many UDP applications will simply ignore unexpected packets, leaving Nmap unsure whether the port is open or filtered, so Nmap places ambiguous ports in the open filtered state. UDP scan, okay. No port responded to the probe packets, and so the all list is open or filtered. One way to better understand which ports. Okay. Nmap version detection does exactly that. We ran SV. Or maybe we need to do SU and SV. Let's try that. SU and SV. SU and SV against port 53. So let's see if. Okay, sorry, continuing. Oh god. Unknown banner. Oh my wowzers. Version unknown banner, but we have something here. Hack the box something. Good lord. What on earth? Unknown banner. Port 53 UDP. All this stuff. I don't know. I doubt that's the answer. Why do I feel that's not the answer? I don't think the answer is this, but maybe it is. Maybe that is what we want. I feel that's not what we want, but it is. Amazing. We somehow managed to do the right thing without really knowing what we were doing. It was a UTP version scan with the SV. Version detection shows beyond doubt. Port 53 is open even when it's running. The other ports are still open. Blah blah blah. They're probably filtered. If you run a service, or if you run an obscure version. So why did that work? Oh, God knows. God knows. No idea. It worked. Same way they had here. I don't really know exactly why it worked or how it worked, but it worked, which is awesome. Okay. I'm going to pause there, go for some lunch. Okay, I'm continuing now. So I had to pause the video. but we're on the hard lab now. So it says, with our second test help, our client was able to gain new insights and send one of his admins to a training course for IDS and IPS systems. As our client told us, the training would last 1 week. Now the administrator has taken all the necessary precautions and wants us to test this again because specific services must be changed and the communication with the provided software had to be modified. So our client wants to know if it's possible to find out the version of the running services, submit the version of the service our client was talking about as the answer. Hint. Our client also mentioned the force added service that plays a vital role for the customer because they require large amounts of data. Okay. Lost track because this is a new day and I've forgotten how to use this. But let's paste that there. I don't know, -SV maybe. Version of the service the client was talking about. I don't know. Is that gonna work? Why do we have to do? You have to do anything else? Let's do it. See what happens. Open SSH. There we go. Service detection performed. Port 80. A client wants to know if it's possible to find the version of the services. Submit the version of the service our client was talking about. And it's something to do with large amounts of data. What on earth? Large amounts of data. I mean, I don't know. HTTP, SSH. Why would either of them be dealing with large amounts of data specifically? Well, let's try both. I mean, whatever. 7.2. I don't think this is right, but let's try it. Nope. And 2.4.18. 2.4.18. Okay. Why would there be a service that we can't see? Oh god, I don't know. I don't know. Anything here that is this supposed to like lead on? This was on a target DNS version. Oh god, I don't know. 869 closed TCP ports, 129 filtered ports. So wasn't there a thing we did last time where we did an ACK scan? Why does the ACK scan require sudo and the others don't? Maybe this will give us something that the other one won't. For some reason, the ACK scan seems to get around filtered ports. Okay, that's not very helpful. Okay, let me pause here and see if I can work something out. Yeah, unfortunately, I can't really work this one out, which is annoying. I've tried a few things. So I tried different types of scan. I tried an ACK scan, which just says 1000 scan ports are in ignored states. I've tried UDP scan with version scanning, and it gave us this NetBIOS NS. But yeah, this version it's not useful. It's not the answer. I tried this, which is a fin scan, I think. Yeah, it just gave us basically the same information as the SYN scan. I tried also fragmenting the packets, which didn't do anything either. It's possible that they're hiding, they're doing something like this, where they're detecting, say, the IDS is forging a package, forging packets or something, so it's pretending to be in a closed state when it's actually open. I guess you can do something where you put traceroute in there, and then you look at the distance, or something like that. You look at the time to live. No, you look at, what do you actually look at? 13 hops. Yeah, so they're looking at two different ports on the same machine. One of them's 12 hops and one of them's 13 hops. And if different ports on the same machine to be the same hop distance, and 113 in this case here is given a reset after only 12 hops. That reset's been forged, so since the firewall is known to forge port 1 3 responses, those packets should not be taken as indicated here. Pin scanning network again using common probe types such as ICMP, CREST, and SIM packets. Omitting any ping probes involving blah blah blah. You can look for IP ID, sequence number consistency. There's all sorts of tricks and techniques which I don't have the time or inclination yet to look at those. Maybe when we do some more of the advanced stuff, we'll look more into these techniques and tricks and things. But right now, I'm happy with the progress we made. You got to the end of this, so I can't exactly work. I don't know exactly what it is because it says as a service plays a vital role. Large amounts of data, so that doesn't really give me any more information, to be honest. They've highlighted 1 week. I don't really know. It says this game because specific services can must be changed. Yeah, there isn't really anything that I can find here that's going to help me. But yeah, as I said, we'll use those techniques when you want to look at some more advanced boxes and some more advanced problems. But for now, we are finished with this Nmap hard lab, Nmap module. So yeah, we'll go, if we go back to paths here, see where we are. We're on the basic tool set, aren't we? So we've now done this one. And yeah, we've also, what have we done? We've done a few things. We've done that one, we've done Metasploit, which wasn't actually on this. But we can, maybe we want to do some login brute forcing stuff next. That'd be quite interesting. Yeah, I think we'll do that. Okay, so remember to like and subscribe. I'm sure that this has been a bit of a longer video, and it's jumped around a bit because I've spent about 3 days making this, but I hope you've enjoyed, hope you learned something, and I will see you in the next one. Bye.